Hi everyone, it's nice to see you guys have joined the Cisco talk. Today what we're going to be talking about is Cisco Meraki, and then we'll have Chandni who will be leading the second half, and she's going to be focusing on the more technical side with MQTT. So what I'm going to be covering within this presentation is more who are Cisco and Meraki, what do they do, what is the company about, and then I'm going to talk a little bit more about the IoT side, so what products fall within the IoT portfolio. So who are Cisco and Meraki? So Meraki is an acquisition of Cisco. So they're one of the leading ones that Cisco has. So Cisco has so many acquisitions, and Meraki focus on cloud managed solutions. So we're kind of focusing on the IoT side today. And what we usually do when thinking about our solutions is we think about what is the customer's problem and how can we actually solve that using our technology, rather than just saying, let's just add this feature today because we have the capability to do that. So we're really focusing on the customer's experiences. So I'm going to start off talking a little bit why Meraki is different to traditional systems. So Meraki focus on cameras and sensors for the IoT side. So with cameras, you'll notice very quickly that you have not just a camera when you're purchasing it from a traditional architecture. You've got somewhere where you need to store the hardware, so a server, somewhere where you need to store all of the footage, so that would be an NVR or a DVR, and then you've got the camera itself, and then you need a specific type of software to be able to view that footage. So very quickly, you see that the camera is just the tip of the iceberg. You've got so many components underneath that are needed just to view that footage. So it's a very, very complicated system. It's not scalable, it's not simple, and it's not secure. But when we think about Meraki, you'll see that everything's cloud managed. So that means everything is stored, all of the footage is stored on the actual device itself. So there's no need for an NVR or a DVR. And like we said, cloud managed. So that means you can access that locally or remotely. So if the camera is in the room, I could view the footage now, or I could view it all the way in Africa, and my experience would be exactly the same. So Meraki is great when thinking about simplicity, scalability, and security. And thinking about your teams, when you're going to be presenting your ideas to the judges, you're going to be having a solution. That's great, you've created that within the short space of time, but is it actually scalable? Will this be working for other businesses? And the people who are judging will be Cisco people. So if you can include things like this, which make it scalable, that would be great, and probably earn you a couple of extra points as well. So let's talk about what actual products we have. So we have the indoor cameras on the right-hand side, and then over here we've got our outdoor camera. They all pretty much do the same thing. Like I said, the video is stored on the camera. So it's just about the type of area that you want to record. Is it a lobby, or is it an outdoor area, or is it a car park, or is it just one room in particular? They all do the same thing, and all these models are sat upstairs, all laid out nice and clearly. So if you want to have a look, have a little feel, lift them, feel how they are, you can do that. And the thing about these cameras, you only need two things to get them going. You need a camera, of course, and you need an internet connection. And once you have them, it's already set up. It's plug and play, it's easy. So when we were setting this up yesterday, I think it took us about half an hour to get all these cameras deployed. Traditionally, it would take about a week or two if we needed to get the entire full stack in, just to be able to record and bring these in today. So you'll see how easy they are to deploy. So what do these cameras actually do? So of course it's a camera. It's going to record footage. It's going to tell you what's going on. But these cameras are different. They can investigate events faster. So that means that we have the capability to actually do things like motion search. So an event has occurred, I need to go and report that to the police. Do I sit there and go through hours and hours of footage to find when that incident happened? Was it overnight? Who was there? No. With Meraki, you can highlight a specific section where the event has occurred, and it will tell you all of the emotion that has occurred in that time over the past half an hour, 2 days, however long you put that for. So it's very, very intelligent. Now, cameras can be a little bit boring. They're just telling you what's going on in the room. But what if you could actually get information from that footage? So that's what we do. Not only do we record the data, but we actually give you information about what's going on. So we can tell you things like people detection, vehicle detection, object detection. So how many people have been walking in and out of this room today? When was the busiest time when people came in and out of this room? Hi guys, you can all come sit down. So, it's a very intelligent camera. It talks to you about smart spaces and you can view trends. So thinking about maybe retail environments, this would be really useful. Thinking about when most of our customers come in at 3 o'clock when we originally thought that it was 12 p.m. So this could be really helpful and maybe something that you might want to use in your solution. I'm going to quickly move on to the sensors now. This is the second part of the portfolio. So when thinking about organizations, you want them to be as resilient as possible. And how do you have a resilient organization? I think it's when you have visibility into your environmental conditions. So that could be temperature data, leakage data. Has something happened in my data center that is ruining my hardware and I have no idea about it? I'm not sure because I need to go on site. Imagine you could access all this information without actually having to go on site. And if you're a big business, you probably won't just have one site. You're going to have one in the UK, one in the US, maybe one in Asia somewhere. So it's really, really important that you can get all this data just by being in one room. So I'm going to talk to you about the different models that we have. I'm just going to quickly skim through this. We have all of them again upstairs, so if you want to have a look at them or take them out of the box, you can. So our first sensor is a temperature and humidity sensor. Again, cloud managed, so no cables needed. Batteries are included, so you literally just pop them in, turn it on, and it will connect to you straight away. So basically, as it says on the tin, temperature and humidity informs you of the temperature. If you want to do something really cool with it, you could maybe link it to a camera, or you could make it a smart sensor and maybe turn down your temperature when it gets to a specific type of heat in the room. You've got a cold temperature sensor. So this works basically within fridges. We've got two different types of cables that stick to the bottom of this. So you'll see in cafeterias, sometimes there's a fridge without a door. That doesn't mean that your food is always cold or always warming up too quickly. So we have a specific type of probe that acts as the food, so you're not getting false alerts. You might open a door 10 times within a minute. That doesn't mean that your food temperature has automatically risen. Maybe the air around it has. So we really focus on getting those exact, accurate results. Air quality sensor. This could be really good when thinking about new spaces that you're creating. Back to work, schools, things like that. So basically, not just air quality, you've got fine particulate matter, which is measured, TVOC levels are measured with this, and then sound levels. So that doesn't mean that it records conversations or it records noises, it just informs you of what the decibel levels are in a room. Next, we have the intrusion sensor. So this works by magnetic field. You have two parts here. I'm not sure if it's very clear on the screen, but there are two sensors and they connect together magnetically. And every time they're separated, where one is attached to the door and one is attached just next to the door, it informs you that the door has been opened. So thinking about data centers where you don't want people to be going in a particular room, or maybe even on a server rack where you don't want that door to be open. And this is really, really important because you can also link this to one of the cameras that we've got and take a snapshot every time someone walks in who maybe shouldn't be. And lastly, my favorite one is the MT30. So this is a smart button and it is literally a button that can do anything you want it to through APIs. Now you might be thinking, I don't know anything about APIs, I have no idea where to start, I don't know what to do with this, but I've got a really good use case that I can think of. What do I do? So what we've done is we have a dashboard and we've given you some examples here. We've got send a notification, camera snapshot, toggle SSID. So all you do is you click on that one and you enter all of the information. So who do I want it to be sent to? At what time? Is it a long press? Is it a short press? Is it any press? So we've created these things for you if you have a couple of ideas. And lastly, send a webhook command. So that's when your ideas get really crazy and you can think about what you want to do. So we've already had some use cases with this button where people have used this in schools. They press the button and at night the Wi-Fi turns off. You don't need to manually go in and change everything yourself. You just literally hit a button, it turns off, hit it again in the morning, turns on. So really, really simple. And it's got such a range of capabilities, it's really up to you. And I think this could be a really, really important feature when thinking about your final solutions. So how do these actually communicate with the dashboard? They're all connected via Bluetooth to an MR and NV. That basically means a camera or an access point. and then they're sent to the dashboard through the cloud again. And security, how do you know that they're secure? So every single Meraki device, whether it may be a sensor or a camera or a net access point, all of them are each of them have a TAM, which is basically a physical chip which goes inside the device, and it means that it can only be accessed by our backend. All of the data is always encrypted at rest and in transit. So just thinking about a use case, I quite like this photo. It shows you how you can protect business infrastructure and also think about sustainability. So you've got a temperature and humidity sensor to make sure that your data center is at the right temperature. So it's not exceeding a certain temperature, and you're keeping it on the right settings for you. You've also got door open and close to make sure that no one's going in. And another one which I haven't mentioned today is our water leak detection. So making sure that your servers are not getting wet, everything is staying nice and cool and dry, and everything's going well. So it's a good example of how you can integrate all of them together, maybe even add a camera in there, and think about how they can all work together and keep your business infrastructure safe. So of course, this is just one example. There are many that you'll be able to think about when you integrate them together. I am going to be passing on to Gianni, who's going to be talking to you a little bit more about specifically the MT30, which is the smart button, and how they can integrate with our cameras and everything with MQTT. So I'll pass over to you.
Thank you. I'm still in charge of this one as well. So let me just quickly share my screen. Can you just pass me presenter or
Yeah.
it says laptop? So while we get that set up, I'm going to take you guys through MQTT. So while we're waiting, just a quick show of hands. Is anyone familiar with what MQTT is? Is it completely new to you all? Do you have any experience with working with it completely? Okay, perfect, because that's how I've kind of gone about this. I was hoping to go through it from the very start, and then if it's too obvious, we can skip things. But let's just go through it from the very beginning. I think I can share now, so thank you, Dee. So I think what you've seen from Dee so far has been brilliant in terms of the kind of kit and hardware that you can play around with during your hack this weekend. What we're going to focus on today and for the second half of this workshop is how can you interact with these? What kind of integrations, APIs can you leverage? And what does it look like? Why is this different from some of the stuff you might have seen in your traditional API sense? So have you guys heard of REST APIs or worked with REST APIs? Some people have, some people haven't. So when you use an API, what you're trying to achieve is have a couple of different pieces of software or machines communicating with each other. So it allows machine to machine or application to application communication. And that's great if you want some sort of cause and effect. For example, their APIs are used everywhere to connect different systems. I couldn't even think of just one simple way to do it. But there's different types of API endpoints that you can have. So an API might allow you to, for example, pull an image onto a web page if a web page is part of your hack, or pull some sort of data onto your app that you're creating as part of your hack solution. And it'll communicate and do that for you from a server where that information is held to the app or where that code is held for your app. You get the REST types and then you get the MQTT types. And the biggest difference is sort of the benefits that come with either one. So it's not that one is better than the other, or you should always advocate for one over the other. It's based on your use cases. With MQTT, what we're looking at is real-time data that you're trying to incorporate into your app or your machine. So MQTT stands for Message Queuing Telemetry Transport. It's always a bit of a mouthful to get that out. And it's a publish subscribe protocol. So what that means is you want information from something, real-time information. And instead of continually polling it and asking for that information, you set yourself up as a subscriber, as in I'm interested in the content you're trying to push out. Now that publisher will continuously produce this content that you're interested in and other content as well. And every time it pushes something out, you will be alerted and fed that information. So you don't have to probe it for info. You wait until it sends something out and you will receive it as a subscriber. So a really good way to think about this is, for example, if you listen to a particular radio, if you have a favorite radio channel, they continually broadcast. There's always something playing on your favorite radio station, but you only hear it when you tune in to their frequency. That's how this publisher-subscriber model works. Content will continually be pushed out. If you're interested and you set yourself up as a subscriber, and you start receiving the feeds that they're sending out. Does that make sense so far? Cool. So that's the kind of API endpoint we're going to focus on today. We're going to go absolutely from scratch. So I've said it's ideal for machine-to-machine communication. On top of that, it's ideal for constrained environments. So what that means is when you want it real time, you don't have time to lose. You're not looking for historical information, you want it real time. So because of that constraint, it lends itself really well to some of the IoT stuff that Dee just mentioned. The cameras, the sensors, when you want to know instantly what the situation or environment is. What is an MQTT endpoint made up of, or connection made up of? There's quite a few different aspects involved. Some of it might seem quite familiar to the analogy that I've given before, so we'll start from the beginning. There's something here called an MQTT server or a broker. What that does is, instead of having that publisher and subscriber directly communicating with each other, which isn't really scalable, there's this middleman, if you like, in the middle that filters content between the two. So it takes all the messages that the publisher sends out. It takes all of them. Doesn't matter what the content of it is, it takes it all. Then it has all of its subscribers subscribe to that MQTT broker, and what the broker will do is say, well, you subscribe to me for this particular piece of information. When that's published, I'm only going to send you that. So it filters the content and it creates that connection between the two. Then you've got the clients. Now you might think of server client as two different entities, and in this case, the server is the middleman of the entire communication. The client can be the application or the process or the machine that sends the information out, but it can also be the listener. A client just means a component that's trying to either subscribe or publish in terms of this connection. Does that make sense? So if we look at some of the IoT equipment that Dee shared, the camera could be an MQTT client because it's sharing its feed, and your app that you're designing as part of the hackathon would also be a client that's subscribing to get those feeds that are being published out. The other important component of MQTT is this idea of a topic. So a topic is how you filter what messaging you're interested in. An example could be with the sensors. I'm interested in getting information about sensors, but not every single thing that sensor picks up. I'm interested in outside filter of all these sensors, so not the indoor ones. And I'm only interested in the temperature that I'm getting. So not the humidity, not the air quality, none of the rest of the messaging. This is particularly what I want. And the filtering of the topic is quite straightforward in terms of human readable. So you can see it narrows down, it becomes more and more specific as you have your forward slashes. So you start with the overarching one, and then you go deeper and deeper into the type of content that you're looking for. So going back to what your hack projects might be, every single theme that you've been given is about making this world a safer or better place in some way or another. Can you use IoT equipment to enable some of that? And if that falls into part of your solution, how are you going to use the equipment to get your feeds? You're going to use MQTT more than likely. So this is how we get set up, and this is how you filter what out of those IoT devices the application is interested in receiving information from. The MQTT broker, the server piece in the middle, is actually really straightforward to set up. Now, I got started with this quite recently, and I was a bit unsure about how difficult it might be to get everything going. Just stepped on a wire and managed to. Hopefully, I've not broken this entire system while presenting. Okay, I think something's going to come back up. Let's see what happens.
Anyway, they just
yeah, Alex isn't here, so you haven't seen him. So the broker in the middle is actually quite straightforward to set up. There are so many free open source MQTT brokers that you can use out there, and I can share a list with you if you want to get picky with the ones you want. I've used Mosquito. It was so straightforward to use, and I don't really yet have a need to try anything else. It seems to do everything I need anyway. So that's the one I'm sharing with you guys today. And let me quickly show you. Okay, that's fine. What we'll do is we'll go straight into the workshop itself. So in true demo fashion, I managed to break something this morning, and I think it's from moving the cameras around. So I'm going to take you through the code anyway. Throughout the day, we'll see if we can get that rectified. The first thing I'll show is this is a live camera feed from some of the cameras that we've got at our Cisco booth, and this is what we're coding against. So when you create an MQTT connection, what you do is you pick this serial number of the device that you're working with and you set it up accordingly. So we've got quite a few cameras you might have seen, some indoor ones, some outdoor ones, some of the ones Steve shared earlier. This is for the particular outdoor one, which has capabilities such as video detection, object detection, vehicle detection, people detection. Now, you might be interested in a specific one of those. So, for example, if I detect a person during these hours, I know something is suspicious. I'm not expecting to see people at this time. Have an MQTT connection set up where you are alerted accordingly to that. You might see the squares come up, so this is why I'm showing it to you. This is how it's detecting that Peter is one of the people there. And it gives you all kinds of information around it. So we're going to see more of that as we go through the code. But we'll let Peter carry on with his great work at the booth without spying on him too much more. And we'll go straight to the code. So, if you want a piece of code that has the MQTT set up, you just have to set up what it is that the publisher and the subscriber is. That's ready for the Meraki IoT hardware. We can share that with you. That's what we're going to go through today. So the first thing you want to do is clone your repo, and I'll share this. I can share this with you if you guys are interested in using it. So I'm going to get my terminal. I've already got this done up somewhere else, so I'm going to start fresh. I'll just check one thing before I start. If I can get this to work, then I've managed to magically fix something. So let's see. And if not, I'll just take you through the code anyway. So not 20 minutes. No, it's only a few minutes. Okay, just 1 second, sorry about this. No worries. Okay, so we've got some data back actually. Good stuff. So what we're going to do is we're going to set this code up. Let me share the code with you now. The first thing you want. Sorry. Oh, I was in the room. No, it's fine. It's okay. So what I'm doing is I'm just refreshing my environment. So I'm not in my virtual environment. Have you guys had a virtual environment before? So when you want to install requirements that your app is going to need, you might be using Python, for example, to code your application. On your laptop, you might another day work on a different project that also uses Python, but not the same version of Python you needed for this particular project. So you set up a virtual environment, which means you install all of your dependencies in this little box that says, I need Python version 3 for this particular project. And then for a different project, you can set up a separate box that says, I need Python 2.7 for this particular project. And it stops them from interfering with each other with incompatibility issues. So we recommend that you always, for any project that you ever do, set up a virtual environment and then start installing any dependencies there. So for the sake of time, I'm just going to take you through the guide, and then we can work together if you're interested in getting this set up. The first thing you want to do is clone the repo. So once you've got your virtual environment set up, and it's very easy to do that. So for example, if I want to set up a new virtual environment with Python 3, this is the command you want to use. So vn stands for virtual env. and then you want to name what your virtual environment is. So I'll put Athena, just to help me remember that that's the one I'm working with. So that's going to create my little box, stops it from interfering with any of my other versions. And then I'm going to activate it. So you do that by typing source, the name of the environment, then activate. So you're just opening this box and saying, right now, from now on, I'm operating inside of this box. Once I've done that, I can install whatever I want. So I'm going to go ahead and install. Let me create a new. So it doesn't mess up. Right now, I'm going to clone the repo. Have you guys cloned repos before? No? It's when you have existing code on a platform such as GitHub that you want to use, saves you from recreating the same code again from scratch. You just download what someone else has already done and contributed to the developer community, and then you can work on top of it or just use it as part of your own solution. So sharing code is a huge practice in the developer community. People are always uploading the work that they've done, free for others to use, maybe with some sort of license, so it's legally protected. But otherwise, it's good to share what you've got, so other people don't have to keep recreating the same sort of functions. So what I've done is I have cloned it. So what that means is now, if you look at what's inside my directory, and by the way, am I going too fast with this? Does it make sense? Okay, so what I've had before is I created a new folder called Athena. So if you go into your normal documents, you might see different names. I've created a new one called Athena, and I did that by using the command mkdir Athena. Then I went into that folder by using cd, which means change directory, and then I cloned this code that already exists that we're going to use to help us today. Now, when I press ls, what you get to see is what's inside that folder that you're in. So we're in this folder called Athena, which was brand new, it had nothing in it before. But now you can see there's Meraki code inside of it because I've cloned that repo. I'm going to go into that folder, again, cd to change directory. Go into there. You can see heaps of code here that we can now leverage. When we start looking at the IoT capabilities and the camera APIs, you're talking about MV-Sense. All the rest of the stuff you can see in the Meraki code is some of the other solutions we have in the Meraki acquisition, but not relevant to the stuff we're talking about today. So feel free to explore and play around, but it's not relevant for what you'd be doing with the hardware that we have on site today. So we'll change into, well, before we change, and by the way, all of this is documented, so I can share this document with you as well, especially with the code as well that you'd need to type in. The first thing we need to do is install all of our dependencies, and that's pre-packaged for us in this requirements.txt. So all the dependencies you need, all the specific versions of the software we're going to be using, that's all pre-packaged. You can install that in one command by doing pip install and then requirements.txt. And also if you press the tab, it auto completes. So that's quite a handy tip. So you can see it's doing loads of downloads of software, and it looks really complicated if you've not seen this before. All it's doing is installing software that I'm going to need in order to run the code. And I don't need to care about what that is or how it works or what version they are. It's not my problem. I know it's packaged up and I need it, so I'll just install it and move on. It's as simple as that. Now that that's done, we've basically done all the admin stuff to get our code going. All we need to do now is set up certain variables. So this is where we define who the publisher and the client is. Publisher and subscriber, apologies, are for this. So if I show you the actual code itself, I got it here. You can see there's only 3 lines of code in here, the rest is all licensing information. What I need to add in here is an access token for something called WebEx Teams. Have you guys heard of WebEx Teams before? It's like Slack, but enterprise to enterprise. So we have, Cisco sells its own version of Slack. We basically compete with Slack on that. It's called WebEx Teams. And it's a messaging platform, a video calling platform, a collaboration tool that people in businesses use across businesses. In order to work with those APIs, you need an access token, and it authorizes who you are, so you're allowed to make changes on that account. I use that for mine because it's really easy and quite fun to integrate Cisco solutions into other Cisco solutions, especially as we have access to it all. And I'll show you an example of WebEx Teams just while we're here. So this is some of my chats, for example. We've got all kinds of spaces here. This is one that I normally use for testing all kinds of code and bots and playing around with stuff. So this is the tool that I'm going to expect to receive the information. This is going to be my app that subscribes to information, if that makes sense. So you'd add in your access token for that here, a few more details about which particular space I want to receive those messages from, and then an API key for the Meraki hardware. So you can see all the connections are already being placed in this place here. Once you've done that, you want to set up your actual broker, so the server that we talked about that sits in the middle and does the connections between the publisher and subscriber. We need to set that up. And it really is, this is what I was saying about Mosquito being so straightforward. You just type in these exact things and nothing else, and it creates the connection. It's that easy. So on the dashboard, where I showed you that camera feed before, let me go back onto it. Let's go onto a camera. We'll go onto the one that we were looking at previously. In the settings for this, if I go to MV Sense, so remember Sense is all the APIs that we can leverage for the cameras. There's all kinds of settings that you can do. So object detection model, body and vehicle. So that's why you're seeing those squares come up around with people who are at the booth. Sense APIs, do we want to use APIs? Yes, that's enabled. Now my MQTT broker allows you to select the broker that this camera is going to publish its information to. It's so straightforward. I literally just copied and pasted those things I showed you earlier into here, and that set up the connection. It was literally that easy. So now my camera knows I need to send all of my information to this MQTT broker. And on the code that I'm going to show you, this is just a snapshot of the most important bits, so we don't go through everything line by line. This is where we set up that WebEx Teams, my messaging application, is going to be the subscriber. It's going to receive all of the alerts that the MV is sending over to the broker. So I'm saying a lot of stuff here, I guess, without diagrams, but does it sort of make sense how these are piecing together? Have I lost everyone? No? Doing all right? Okay, cool. So this is what we have. And there's three main components. The first bit is we just need in our Python code that we've got an MQTT server, and we write that same copy-paste. I changed the .io to all because it worked in my case, so that's something you can do in yours, but otherwise it's copy-pasted. The same with the port number, so that's the port that it uses to communicate on. Then you've got a second piece of code that you will see when you clone this Meraki code that I'll share with you. And it's just to set up that you've got the client, and then you're going to set up a connection here with the server, the port, and then the time at the bottom over there. And then you let it continue forever. So when you actually run this code, what you'll see in your terminal is that it continues to run until you forcefully stop it. So it will never stop sending me these snapshots of people or object detection until I ask to close that connection, which is quite handy. And then finally, what is the topic that you're interested in? And I'm going to share with you all the different topics you could subscribe to if you choose to use the MQTT from Meraki IoT. The way it works with the topic, literally it's like that / thing we talked about. I'm interested in Meraki MV, which is Meraki Vision. It means all of our cameras. You put in the serial number for the camera that you're interested in, and depending on what you follow that with, it goes into a little bit more detail. So /0 is just basically your default. I want everything that this camera with this serial number sends me. Then you can filter that to make it more and more specific, and we'll go through those in a second. And then last line here is literally client.subscribe. So it makes it really, really straightforward. And this is what you'll see in your code. Now, what should we go through next? So you've got information on how to install it. Apologies. And again, that's one line of code. and then how you set up the connection. Show code you guys would use regardless of what camera you choose, because that's the network we've set it up for, and then these X's, you replace it with the serial number of the camera that you're interested in. So I did it just a second ago. Let me change back to where I was. I'm going to deactivate this virtual environment and use one that I've set up before.
I have a question.
Sure.
So if we want to record this data, how does that work? Is it so when it's like when you're watching the people interacting on the camera, is it like recording when it sees people to a database or something, or would that be like an additional thing you need to add?
Always recording.
Yeah.
Always, yeah.
So how do you access that data?
That would be through the dashboard, isn't it? Yeah, we've got a dashboard that all of the camera stores its footage. So we could give you access, isn't it? We just have to set up an email address. So yeah, where the orange bar is, because it's right by the booth, that's all the motion that it's recording at the moment.
I see.
So
Does it record it just as a video format, or does it actually record, I don't know, like the time and the number of people or something? What sorts of data can we get from?
it wouldn't tell you the number of people. It would tell you that there is people, and maybe the coordinates that they're in the frame. And you wanted to know if you could get the footage? Is that what you asked? Sorry.
No, so I was just wondering, like, what formats of data and what exactly it records. So obviously it's recording the video, and then the coordinates it gives, and whatever it detects people.
Yeah, so
Is that like another table or something like that?
yeah, you can do like heat maps and motion area where you have the most motion, trends and stuff. We can give you that sort of stuff. Sorry, go on.
Also, when you set up the MQTT subscription, there are different ways that you can do it, and I just want to share that with you quickly here. And that's kind of answering your question around the coordinates. Depending on what topic you subscribe to and the level of like nicheness and the filter you have for it, you can either do how many people entered and left my frame, and it will give you that information, or you can do raw data, which is exactly what you can see in this diagram. It gives you the timestamp of when it saw the object, and it gives you the top left and the bottom right coordinates of the square that it builds around the object. So that's where you get information around what you saw, where it was, what the coordinates within your frame are. Does that answer the question?
Yeah, that's perfect. And how do we access that? Like, is that, if you want to pull like all of the data, say, that was gathered in 10 minutes, how do we do
You
that?
would use a REST API.
Okay.
So what we're talking about with MQTT versus REST, this is an exact example of how they both have their benefits. MQTT is for that real-time feed. I want to know right now what's going on, which is why we don't close that connection until we're finished. With REST APIs, it's about historical data. In time span X to Y, what happened? How many people were detected? How many objects were detected? And I can show you on the Meraki API documentation how you would construct an API that gives you exactly that information. You just specify your start and end time for your frame. In certain cameras, you can do zones as well. So for example, I want to focus on the entrance of my retail shop, not everything you can see in your camera view. And I want to know in that particular zone between time X and time Y, how many people came in. So again, for retail, a great use case of how you can use the IoT equipment. But that would be using a REST because it's historical data. This is MQTT because it's real-time data. But it's all possible using an API. Does that answer the question?
Yeah, thank you.
Good stuff, no worries at all. I know we've got about 5 minutes left. I don't want to go running through the code, just especially because I complicated it this morning with something. But is there any other questions I can answer in the last 5 minutes? Or anything you want to talk more about once we finish the session? No? We're all good? Okay, we've got the hardware at our booth, like Dee said. Please feel free to come around, have a look at it, play around with it. We just need to give you an API key for you to have access. So it's really quite straightforward. And we can take you through some of the things that we've already seen and done and talk through how we've seen customers use this kind of thing. I mean, I've only really talked about cameras today, but Dee mentioned the buttons, she mentioned sensors. Think about how if you integrated those three things together, for example, if a sensor detects this particular environment, take a snapshot of the room. If the intrusion prevention door, a sensor goes off between these hours, take a snapshot because someone's opening that door that shouldn't be doing it. You can make these things talk together by using REST APIs, and we can help you with that.
So in terms of like AVs and autonomous vehicles, how well would the camera or the sensors work? Like in terms of motion outside, because the examples you showed us is like it's just stationaries in one place, just showing us like people that are moving, but what happens when it's moving, and also recording that when people move as well.
That is a really good question. I haven't tried it while the camera is moving.
The cameras, do you mean like when they kind of rotate with the head?
Kind of.
Like a PT
Like also like in motion as well. So if I was to carry that camera around, like how would it take in that data? Yeah.
I would say we haven't really dealt with that yet because all of the cameras that we currently have are ones that are usually like installed in a wall or in the ceiling. They're usually stationary most of the time. There's only one camera that we have that you'd probably just leave on a desk, which doesn't have the same capabilities. So right now we've only got cameras that are stationary for like 90% of the time, if that answers the question. But maybe that's something we could think about.
Yeah, and they're all wired, aren't they? None of them are Wi-Fi, right?
No, they've all got PoE
Yeah.
connection, so they need to be wired in.
Yes, they're not very mobile, I guess,
Yeah.
at the time being. The ones that we've got, I guess the Meraki portfolio addresses businesses that have a requirement for security cameras. Then it does this additional stuff that is really useful as a security team. For example, detecting people and vehicles. So I know that there are companies who use these cameras and say, if you detect a vehicle coming on a day when I have a customer event, take down the registration number, set up a guest user on the Wi-Fi for that person, that car's owner, and that's all done before that person parks their car and walks into the door. So for a business, that's a great use case. But if you want to start moving that camera around, you'd have to think about how you'd move the wire that it's plugged into. It's just a bit impractical for the time being, if that makes sense.
I have another question. Just so I understand, because this is all new. So it's like MQTT and what did you put up on REST type? Is it like, so is MQTT kind of like, this is the analogy I'm using in my head, so like videography, but then REST type is like photography.
Yeah, exactly. So you can think of the REST as, I want this information, let me request it. Okay, you've given it to me. Okay, now I want this, let me request it, give it to me. Okay, now I want it again. It's a bit tedious when you want continuous streams of information. That's where MQTT comes into. So it's like that radio analogy. You tune into the frequency of your favorite radio station. It's not like, give me a song on Spotify, you get one song, and that's the end. It's like tuning into your favorite radio station where it continually plays. And once you're done listening to that radio, you tune out. That will continue playing for everyone else.
How do you store that one idea then? Like if it's continuously?
So that's where the MQTT broker would be handling that. You would only subscribe to the bit that you're interested in. And then if you're subscribing to a lot, you'd have to have some sort of storage solution in place for that. It depends how much information you're trying to gather.
So, sorry. So if you want to store data that's constantly coming from MQTT, you wouldn't need the REST API, you would need another MQTT solution? Or how?
I think you need a storage solution.
Right.
If you're requesting a lot of data. I haven't ever set that up myself, but I imagine if you're requesting a lot of information from a publisher, you're going to need to have some sort of storage solution in place to store that data, unless you want it for the time that you receive it and then you get rid of that data immediately. So it depends on your use case. If you want to store that to review again in the future as historical data, you can. But then if you're interested in historical data, REST is what you want to go for. So I imagine you'd need to set up your own storage if you want to get real-time view of the camera feed, and then you want to go back to that yourself later, you'd need to find a storage solution for that, as far as I'm aware. Unless there is something that exists that I don't know about.
Sure. So for the server, like, does it then store like all the information that's picking up from the publisher, or does it just like transmit that through?
I think it stores it until it gets subscribers. So I don't know too much about the server itself. The whole point of the broker is that you don't have to worry about that complexity. It does it for you. And I haven't looked into how it manages to deal with that complexity. But as an end user of that model, you just need to know that if I'm interested in this piece of information, the MQTT broker will get it to me. How it gets that to you in time, or where it stores it until you start subscribing, I don't know how that would work. But it would save you hassle, I guess, more than anything else. Any other questions? Cool. Well, thank you all for coming down. I hope you found this session useful. We're around for the day, so come down and ask any questions, play around with hardware if you like, and let us know if you decide to use any of it in your hacks.
Thank you.
Thank you.